Good morning all. Myself B. Praveen Kumar, and this is our project Smart Irrigation System done by A. Sai Kiran, G. Priyanshu, A. Naresh, and myself B. Praveen Kumar. Our main aim of this project is to design a smart irrigation system which is capable of detecting moisture in the soil. Accordingly, the system will take a decision to switch on or off the motor. To make this system smart, we are using Arduino and several sensor feedbacks like moisture sensor, LDR, and rain sensor. Here we are also using a regulated power supply which is capable of supplying 5 volts DC, and also a relay module circuit which is used to drive the single phase or 3-phase AC motor. The is to decrease and reduce the electricity and water content which is used in agriculture, and also minimize the human interfere in agriculture fields. As I already explained, the we are using Arduino system to implement smart irrigation system. This Arduino requires regulated power supply to drive the system and also load the program. And this system is using 3 sensors named moisture sensor and LDR rain sensor. The ultimate output will be taken from moisture sensor only. As we already see in our LCD display that the motor is off as the moisture is high. This we can witness here. The moisture sensor is already dipped inside the system water, so the moisture level is sensing high and the motor is off. Now as we see here, the moisture is high and the moisture sensor is sensing high moisture. Now I am removing this moisture sensor. As we can witness that motor is on, and also in display it is shown that the motor is on and the moisture level is low. Again, if we dip this moisture sensor inside the water, and the display is like motor is off as the moisture level is high. Okay, coming to the main components of this project, this is the LCD display which is used to indicate whether the motor is on or off, and the level of moisture whether it is low or high. And this is the water motor. This is the final AC motor which will be driven by using relay module. This is the relay module. Where it is capable of drive a single phase or 3-phase AC supply by using a short AC DC auxiliary supply. And this is our moisture sensor, and this is the ultimate output. We can take analog or digital output. And this is our LDR light dependent resistor. This is used for low rain, whether the atmosphere is cloudy or lighty. And we can also check the operation of this LDR sensor by creating a darkness over the sensor. And coming to the rain sensor, this is the rain sensor, and it is also used for the purpose when the rain is the atmosphere is rainy, then our motor should not operate. However, the final output will be taken from moisture sensor only. If the soil, even though the atmosphere is rainy and the moisture sensor doesn't sense any water, the motor will on. And this is our main Arduino system. This is the heart of our project. Here we connected a aux cable which is used for loading the program. This is our program. Generally this Arduino is capable to operate even after without connecting this aux cable also. But here for the purpose to demonstration we connected this laptop. Coming to the challenges of this project, we are using Arduino to make the system smart, to make smart irrigation system. But in the market there are many other systems also available like IoT based smart irrigation system. The main comparison, if we compare our system with other IoT systems, the main disadvantages of IoT system is it depends upon purely internet and also mobile. As it involves in IP address and system data, there may be many chances of hacking also. And also to implement IoT project over this smart Arduino system, the cost compared with this system is very high. And also IoT systems we need to see and monitor. As in case of this, we need not to see. Comparing this Arduino system with IoT based smart irrigation system, the control by using IoT system is very difficult. As IoT solutions are in place, remote hackers can seize the control of applications. If they hack the system, then the control of pesticides and the water control is not in our hand, and it may changes according to their action. So in this Arduino system, we can change the program accordingly crops and fields. We can set the moisture level, and accordingly water will be supplied to the fields. There are many irrigation systems are available, like drip and sprinkler irrigation systems. In that, the each has its own advantages. When comparing with the drip irrigation system and sprinkler irrigation system, in drip irrigation system there might be a chances of scale formation inside the pipes. So according each crop, and we also know that the individual crop needs individual water supply. Some crops like many crops need high water content, and some crops need a very low water content. The water content to the crops will be controlled by programming these systems. As we also avail sprinkle and drip irrigation systems, which will be supported by this Arduino system. Coming to the advantages of our smart irrigation system by using Arduino, there are many advantages like easy operation and maintains crop quality, enhances crop yield, saves water, project water resources. And the first thing is automatic soil moisture sensing system, and also we are switching on off motor by automatically through sensors, and also by using Arduino. So as no human is interfering into the system, the main heart of our system is Arduino. It can able to control the motor automatically, and this is the main advantages to switch on the motor. And also the system is highly efficient and low cost design. As we can see here, we are using very less number of moistures to as a feedbacks to operate the motor, and it can be easily operable. As we can see here, the moisture sensor can be dependent. If moisture sensor senses wet, the motor will off. If moisture sensors doesn't senses any, and it senses dryness, then the motor will be immediately on. Coming to disadvantage of this project is, the main disadvantage of this project is power failure conditions. If power fails, we can't able to supply or drive the Arduino and also drive the AC motor. For that, we are compensating the system by using a overhead tank, where after supplying enough water to the fields, we are supplying water to the overhead tank by using the same motor, which will able to store the water in the overhead storage tank. While under the power failure conditions, if the same system will sense the moisture level, however, the supply is failed, as the relay module is consisting of two contacts NO and NC. So we are using NC contact to operate the motor. As the overhead tank having a head difference, the overhead tank water will be naturally supplied to the crops. So finally, this is our project, smart irrigation system by using Arduino, which was done by batch 18 of team members A. Sai Kiran, A. Naresh, G. Priyanshu, B. Praveen Kumar, under the guidance of A. Lavanya ma'am. And also we thankful our T. Rajesh and G. Rajshekhar sir for supporting us to make this project. And also we gratefully thankful to our beloved HOD sir, Dr. P. Durai Pandey sir, for giving an opportunity to do this project in our major project. Thank you all.